This week I have to cover 2 more sections to finish the exam ranges material because exam will be up to 3.3. Let's start with 3.2. Three 3.2 is about trigonometry integrals. Let me give you the strategy for evaluating certain pattern of the trigonometry integral. Let me just stating first, if the power of secant is even, then we will use secant squared of x equals 1 plus tangent squared of x, and u equals tangent of x, and du equals secant squared of x dx. So in this case, the power of tangent doesn't matter. So the power of the tangent may be even or odd. So we have the integration of tangent nth power x times secant nth power x dx. Then in this case, we will use secant squared of x equals 1 plus tangent squared of x. And so we will split this into the 2 pieces. Tangent of m x times secant of n minus 2 x times secant squared of x dx. So by doing that, what we want to do is we want to use the u substitution, as I said, and then for this part, by using this formula, this can be converted into tangent related expression. And this part will become du, right? And so everything is tangent, and then the u related terms and du. So it'll be like usual polynomial. The second pattern is if the power of tangent is odd, then we will use tangent squared of x, the same formula, but we will solve for tangent squared. So tangent squared of x is secant squared of x minus 1, and the u equals secant of x, and the du equals secant of x times tangent of x du dx. So integration tangent to the m power x secant to the n power x dx. Then this time tangent is odd power, but we will use this formula. So we will split that into two terms, and we will use this part. And so secant will be split into two parts again. So tangent to the n-1 power x times secant n-1 power x times tangent of x secant of x dx. So this part will become du, and this part will be secant related. Expression. And we put u is secant of x, so that means this part will be just a u related polynomial, and then this part will be du. For the exam, it's extremely important to know what the strategies are, not only this one, but also all other parts. So this strategy is something you have to clearly remember, and you have to do u substitution correctly. Otherwise, there is no way to make a progress with the problem, because you cannot start the problem. So clearly remember, if secant is even, then you will use this formula, and then you will do, and then you will see what you have to do. And if power of tangent is odd, then you will use this strategy. Other common formula which will be used in this section will be integration of tangent is natural log of secant of x plus c, and the integration of secant of x dx equals natural log of secant of x plus tangent of x plus c. If you look at the lecture note, then you will find a lot more problems which I worked out, but definitely we have to cover 3 sections in 2 sections in 3 hours. So I will not go through the problems, but you can refer to the lecture note. Lecture note is already posted in our course website. So the problem is tangent of 6th power x times secant of 4th power dx. So in the previous statement, this falls into secant is even, right? So we will use each strategy. So what you have to think about is you will use secant squared of x equals 1 plus tangent squared of x. And when you differentiate tangent of x, you will have secant squared of x. So integration tangent to the 6th power x times secant to the 4th power x dx. So that is tangent to 6th power times secant squared x times secant square root of x dx. Tangent to 6 power times secant squared is 1 plus tangent square root of x times this one secant square root of x dx. By doing that, when we do substitution, this part will be polynomial. And this will be the differentiation of tangent, right? So we will put u equals tangent of x and du equals secant square root of x dx. So this one will be tangent 6 power is u to the 6 power times 1 plus tangent squared is u squared times secant squared is du. So we do integration u to the 6 power plus u to the 8th power du. So that becomes u to the 7th power over 7 plus u to the 8th power. U to the 9th power over 9 plus c. So that equals 7. Tangent 7th power x plus 1 over 9 tangent to the 9th power x plus c. As you can see, these part are pretty easy. So as long as you figure out the strategy correctly, the remaining step will go easy. Let's do a different pattern of the problem. The second one is integration tangent to the 5th power x times secant to the 7th power x dx. If you look at the pattern, then there is an odd power with tangent. So we will use tangent square root of x equals secant square root of x minus 1, and the d secant of x equals tangent of x times secant of x dx. Now we have integration tangent to the 5th power secant to the 7th power dx. What I said was in this case, we will just split that into 2 parts for each. So I will rewrite this one as tangent to the 4th power x times secant to the 6th power x times tangent x times secant x dx. The reason we do that is we want to do u substitution with secant. The derivative of secant is tangent of secant, and to use this formula, the power must be even power, even degree power, right? So this one can be understood as tangent squared of x squared. So this one will be integration secant squared of x minus 1 squared times secant to the 6th power x times tangent x times secant x dx. So I said we will do u substitution with secant. So u equals secant of x and du equals tangent of x times secant of x dx. By doing that, this part will become du, and this one will be just a polynomial related to secant, the u. So after u substitution, we can write that as u squared minus 1 squared times, this is u to the 6th power, times this part will become du, right? So to solve the problem, we will put this one is u to the 4th power. We do this part, then 2 u squared plus 1 times u to the 6th power du. So that can be written as u to the 8th power. We do distribution minus 2 times u to the 10 power, right? 10 power and then 8 power plus u to the 6th power du. And then common sense rule is applied. So it becomes u to the 11th power over 11 minus 2 times u to the 9th power over 9 plus u to the 7th power over 7 plus c. The remaining step is only about the substitution. So to finish the problem, we will put secant back to u. So that becomes secant to the 11th power x over 11 minus 2 over 9. Secant to the 9th power x plus this one is secant to the 7th power x over 7 plus c. So there are more problems in the lecture note. You have to go through it when you, at least when you do your homework, you will have to refer to that. Some of them may be slightly confusing. Let me move on to the strategy for evaluating the sine and cosine combination. The first case looks like this. if either m or n is odd, then we will use the Pythagorean formula. Which was sine squared plus cosine squared equals 1. And then we will apply it to the odd degree powers one. Of course, the odd degree must be splitted. So that we make it to either integration sine to the k power x times cosine of x dx, or integration sine of x times cosine to the k x dx. Of course, the idea behind that is after you apply this formula, the just one of them must have single degree term, because the because when you differentiate sine, you will get cosine. When you differentiate cosine, you will get negative sine. So then we use a U substitution. The U substitution will go like U equals sine of x, and du equals cosine of x dx, or U equals cosine of x, and then du equals minus sine x dx. So this is one of the strategy. When one of them is odd, if both m and n are even, so that in that case, the circumstance become a little more complicated. So our strategy will be lowering the degree by using the half angle formula. So we will use sine square root of x equals 1 over 2, 1 minus cosine of 2x. And cosine square root of x equals 1 over 2, 1 plus cosine of 2x. Of course, this half angle formula must be remembered. So as I said, the basic strategy is just lowering the degree from degree 2 to degree 1. And then when we lower the degree, it will become the first case, right? So that we make the integrand to odd degree powers. Sine of x and cosine of x. Let's do the examples. We have to evaluate integration pi times sine cubed 3 pi x times cosine cubed 3 pi x dx. Then we can write pi in front of integration. So pi times integration of sine cubed 3 pi x times cosine cubed of 3 pi x dx. We want to split sine. Then it becomes pi integration cosine cubed of 3 pi x times sine squared of 3 pi x times sine of 3 pi x dx. You can choose to split this one also.
Professor, you wrote secant instead of sine.
Oh, sorry, thank you. Sine squared, yeah, sine squared 3 pi x. So that is pi integration cosine cubed of 3 pi x times this one by Pythagorean formula becomes 1 minus cosine square root of 3 pi x times sine of 3 pi x dx. So we put u equals cosine of 3 pi x. And we think about du, then that is minus 3 pi sine of 3 pi x dx. Therefore, minus 1 over 3 pi du equals sine of 3 pi x dx. So that is pi times integration u cubed times the next one is 1 minus u squared times negative 1 over 3 pi du. So let's just write all things clearly. So we can put this one in front of integration, and we calculate this part. Then that is u cubed minus u to the 5th power du. So that equals minus these two will cancel each other, 1/3 u to the 4th power over 4 minus u to the 6th power over 6 plus c. And then we just do the final substitution. Then that becomes 1/3 cosine to the 4th power 3 pi x over 4 minus cosine to the 6th power 3 pi x over 6 plus c. So once you get the correct strategy, when substitution is done, it should be pretty easy. But if you don't know how to start it, then it'll be difficult. So when you look at the problem, what you can see is just a sine and cosine are combined, and derivative of sine is cosine, derivative cosine is negative sine, and so you will have slight sense of just substitution or intuition. So your intuition will tell you maybe if one of them become like just a sine x dx or cosine of dx, then it should be fine, but the remaining one must be even degree if we do substitution with sine, and then the remaining part must be even degree for cosine to use the Pythagorean formula for the substitution. The next one is negative pi sine squared of 5x times cosine squared of 5x dx. In this case, I said you have to use the half angle formula, which goes like sine squared of x equals 1/2 minus 1/2 cosine of 2x, and cosine squared of x equals 1/2 plus 1/2 cosine of 2x. We can write this one in front of integration. So that becomes minus pi integration sine squared of 5x times cosine squared of 5x dx. So that can be written as negative pi sine squared is 1/2 minus cosine of, this time this is 5x instead of x, so we will double it. So 10x over 2 times 1/2 plus cosine of 10x over 2 dx. The expansion formula we will use will be a minus b times a plus b is a squared minus b squared. So when we expand this, or you can use FOIL if you cannot remember the formula. So it becomes integration 1 over 2 squared is 1 over 4 minus second term squared will be cosine squared of 10x over 4 dx. And then this is a second degree term with cosine, which we don't have the handy formula. So we will try to lower the degree by using the half angle formula. So that is minus pi integration 1/4 minus 1 over 4. For this part, we use the second formula. So that is 1 over 2 plus 1 over 2 cosine of the double angle of this one, which is 20x dx. So that is minus pi integration 1/4 minus 1 over 8 minus 1 over 8 cosine of 20x dx. And then this part, this one is 2 over 8. So when we combine these two, we get 1 over 8. So minus pi integration 1 over 8 minus 1 over 8 cosine of 20x dx. And then this is just a common integration, so we can finish it easily. So this becomes minus pi, open parenthesis. First term's integration is 1 over 8x minus 1 over 8. The second term's differentiation will be when we integrate, you will get sine. So sine of 20x, but we have to divide by 20. So plus c. So that becomes minus pi 1 over 8x minus 1 over 160 sine of 20x plus c. Let's do a little bit different pattern of the problem. The next one is about integration 0 to 3 pi over 2 cosine cubed of x dx. So 0 to 3 pi over 2 cosine of 3x dx. What we want to do is if we split the cosine into cosine squared of x times cosine x dx, Then when we convert this into sign related term, this one will become a cosine, or the derivative of sine. So we will do like that. So it becomes a 0 to 3 pi over 2. We use Pythagorean formula so that we get 1 minus sine squared of x cosine x dx. So u equals sine of x, and du equals cosine x dx. And we are changing the variable, so we have to change it the lower and upper bound of the integration. So if x equals to 0, then this substitution, sine of 0 equals 0. And if x equals 3 pi over 2, we just think about the graph of sine. This is pi, this is pi over 2, this is 3 pi over 2. Then so this was u, right? U equals sine of 3 pi over 2, which is -1, right? So it becomes like this. Let's convert all those. Then lower bound became 0, upper bound become -1. It doesn't matter whether this one becomes smaller. That's reflecting certain the orientation concept. So 1 minus u equals sine of x. So sine squared of x is u squared, and cosine x dx is du. So that is u minus u cubed over 3 from 0 to -1. So that becomes u is -1 minus u is -1 cubed over 3 minus u equals 0 minus 0 cubed over 3. And so this one will vanish. And so that becomes -1 plus 1/3. Right, so minus minus will make plus because this is odd degree power. So the -3 over 3 plus 1 over 3, which is -2/3. Any question? So what is it? As I said, it is extremely important to remember all the strategy here. Otherwise, you cannot start the problem. So just you have to go through not only this content, but also the all other content. Just make the formula sheet separately and summarize the strategy and typical examples so you learned or in the lecture note, so that you can start the problem correctly. And tomorrow we will meet on campus and we will do some activity. And the exam problems will be very reasonable in the sense that as long as you mastered it, then those are very straightforward problems. And that will be the combination of the problems. I mean, you have to write all the details and you have to graph to start the problem. And no, there are some multiple choice problems. I think that was very fair. I think that'll be very fair exam. So just if you study hard, and then you will get a good score, I believe. So do you have any question? And the exam will happen 8 o'clock next Tuesday. I believe I gave you the room number. I think it was 201 in classroom building. You have to check the announcement again. And it'll be 1 hour, 30 minutes exam. If you're in a SAS student, and then I've heard that the testing center will coordinate the uniform exam. So on that day, all the students in SAS will take the exam together, rather than the time you're selecting. So that will be informed to you if you register for testing as SAS. So do you, I don't think there is any problem which is related to the approximate, but what I can say is test problems will not give you the overly complicated numbers. Those will be very reasonable and neat numbers. And I cannot remember how many multiple choice are in the exam, but there are several multiple choice problems. And those will be combination. I think it may be half and half, but definitely the problems which require the written solution will have more value, larger value. Do you have any other question? For the multiple choice, I don't believe in so, but I don't think so, but I will double check it with the coordinator. Any other question? Okay, that's all I can give you about the exam related information. Tomorrow, we will do in-class activity. We will go through a little bit basic basic background related the review together. I mean, just activity form, and you will solve some problem. Tomorrow you have to bring quiz 1 and 2 and turn that in. All right, and so see you tomorrow in the classroom in person.